and also for PhD. He served as a member of faculty recruitment committees of various IITs, NITs, universities, etc. He is having life membership of various organizations. And Sir participated as an Indian delegate on brain imaging in the trilateral meeting of India, Canada, Israel. He attended many national and international conferences and chaired several sessions. He has delivered several keynote lectures as well as seminars. Now I request to Dr. Ramasubba Reddy Garu to continue with the session. Thank you, sir. Thank you for giving this opportunity to me.
Thank you, madam.
Thank you, sir.
Okay, shall I just go for screen sharing mode?
Yes, sir.
Yeah. Yeah, am I visible, madam, my screen?
Yes, sir. Yes, sir. Yes, sir.
Yes, thank you. Yeah, very good morning to one and all. First of all, I should thank Sridhar for taking up this very useful and very laborious task. I mean, at this condition, I mean, getting permission from AICTE and then conducting this course by conducting different research people. And all participants also being in the, say, in a restricted moments here and there, they could able to participate in this meeting. Yes, and this has given us an opportunity also to quickly update or upgrade ourselves to participate in this sort of online conference, online meetings, or maybe seminars, whatever it is. And I think maybe sometimes some inconvenience also is helping us to learn things. Okay, coming to our today's topic, that is machine learning. Of course, in past 5 days, I mean, you might have just heard of machine learning fundamentals and these sort of things. Probably this lecture, I will show an application, how the machine learning is used for biomedical applications, and maybe the current active or maybe very demanding topic as a brain-computer interface. And maybe once you understand the steps, probably you will also may start in that line. So in that, with that view, I think I am just trying to spread this news to everyone. All that what you have to do is, because all of you are ECG background students, though if not biomedical background, sorry, not students, sorry, faculty, I think we will just take up this sort of activity and then try to put in our ideas and then bring in a very feasible help or maybe a good say gadgets to the people who are really needed this. And if we, so slide has changed, please. Any one of you can respond. Sometimes the slides may not change. Now I have gone to the second slide.
No, sir. No, sir. Not changed.
It is still in the first slide only, right?
Yes, 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 yes.
Up. Now?
No, sir. No, sir.
No?
Now it is okay, sir.
Now it's okay, right?
Yes, sir.
Yeah, I don't know. Maybe when I go for full slide mode, I mean, it's not changing in this Zoom. We will try to run in this edit mode itself.
Okay, sir.
Yeah, anywhere in the lecture, if anyone finds some question or maybe something to be clarified, please try to raise your voice, or maybe unmute your mic and then please raise the question. Because if you try to keep to the end, I mean, end may not be that free for us, because we have to rush through a lot of slides. Maybe whether we'll have time for free questioning at the end or not, I mean, we don't know. Please try to raise questions whenever you get some doubt. And maybe the first one, what I try to see is the ideas must work through brains and limbs of human, or they are not better than dreams. So this is the one what generally I quote here. So whenever we get an idea that has to be implemented, unless we implement, there is no use of having an idea with us. So that's the way that what we can think. So that implementation will be through brain and limbs of human. So brain has to execute the a different plan, or maybe the exact plan what we have to do, and then we have to implement it. So that's the way that what all our ideas will work. Let us go through how we can say. Now it is changed, no?
Yes,
Hello?
yes,
Ah,
yes,
okay.
sir, working, sir.
Yeah. Okay, good. So the machine learning, what you are talking for the past five days, I think I am just introduced a few review, or maybe just overview slides. So machine learning is a application of artificial intelligence which makes, or which automatically learns from the experience and without it being explicitly programmed. So the artificial intelligence helps the computers to learn automatically with the example. So that's the main theme of the machine learning. And what we can say is, by providing examples or our experience to the computer, we will be able to make the decisions made as per required, as they are supposed to be done. And as we say, computers learn automatically without human intervention. So this is the main theme of this machine learning. And this can be done unsupervised, unsupervised, or semi-supervised. I think you might have come across these terms in past few 5 days. And this block diagrams show the, say, traditional programming. So if we have data, and this data has to be organized in some way, as we say, as a clusters or to some groups, whether normal or abnormal, whatever it is. So these groups, and for that we will write some rules. I mean, what would be the normal, what would be abnormal, and these sort of things. And then when we traditionally program these rules, then we can get answers. Rather, in our machine learning activity, what we try to do is, we'll have data and answers. I mean, what it's supposed to be, or what are the patterns that we are supposed to, we may get it. So if we could able to give it to the module, as a machine learning module, it will come out with a rule how to organize this data. So this process, what we call it as training the system or training the machine. And once we get this rule, and this rule will be applied to data like what we are doing earlier, and then we can get answers. So that's the way what we can simply put it, the machine learning process. And real world machine learning, where is this machine learning is being used? I think that every one of us have come to an understanding. So we know we have these automatic systems everywhere. See, automatic transition, or maybe traffic traffic predictions, search engine results, online, or maybe image recognition, virtual personal assistance. So a lot of this system places, now this machine learning has come, and then it became very important. So all that what we are putting it as a mission is the brain. So whatever a brain can take a decision in appropriate condition, so we are trying to put a mission and then try to see how the brain decisions are being implemented in the mission. So that's what we'll be attributing as a machine learning process. And what we call the brain, so all these ideas or maybe whatever that we are doing, performing activity is the brain's ideas or maybe brain's organization. Whatever we say, a decision is taken, that brain will look into the data and it will take appropriate decisions. So those decisions, what we can call it as, say, in that sense, brain is called as a creator of reality. And here, if we just see that communication is vital to survival of any living organism, so that's what we are doing day in and day out here. And these organisms have developed the communication system, which is called as nervous system. And this nervous system controls and coordinates all essential functions of human body. And human nervous system consists of brain, spinal cord, and nerves. And the fundamental unit of nervous system is neuron. So, of course, for people who, I mean, this is a very general statements. This is people who are not biomedical or maybe who have not, say, having any introduction. I think this you can just consider for communication system, for communicating, nervous system is developed in the human body, and this controls and coordinates all the body activities. That's true. As we are speaking, or we are watching, or we are sitting, everything is now controlled by our nervous system. Though we don't feel it explicitly, but internally it has to do it. And whether we are sleeping or awake, or we are functioning any activity, that there is the function of nervous system behind all these things. And this nervous system is divided as brain, spinal cord, and nerves, which will be connecting the limbs or maybe the sensory systems to the external worlds. So these nerves will do that. The nerves in turn will report to the spinal cord, or will come from spinal cord. Sorry, spinal cord in a sense go to brain, and brain will be the storehouse or maybe control room where the information is being done. And then in the brain, or maybe even in nerves, all that what the entire system is a neuron based organization. Like our building, all that building we can see walls and big structures, but in that the basic unit of it is a brick. One brick will be there, another brick will be joined to together, and then it can be put on the side so that the wall becomes wide or maybe tall or whatever it is. So the whole structure or maybe the nervous system is made up of neurons. So this is the way that our communication system has developed inside the body. And if we look at it, you see here, if a person touches, if we want to give some signal or some call a person, first there will be a touch that happens on the shoulder, and the neuron. So actually, a neuron is like this. We'll see in a detailed way a neuron. It goes and it will report to the brain, and brain will process it, and the decision is made, and decision is communicated via another neuron, and it will go back to the appropriate place. That is, maybe a person is calling, so maybe the head has to be turned in that direction to acknowledge the signal that has been given by the hand. So this is the way that what it happens. So it's not that the human part or maybe the muscle that is near, let us say, shoulder, is executing the complete activity, and then it is turning the head. Actually, the information is being transmitted to brain. Brain will take decision, and the brain, the decision will be communicated again back to appropriate points. So it is just like a telephone exchange. So whenever we speak, that will go to the telephone exchange. At telephone exchange, to whichever part that has to be communicated, so that will be connected and that information will be passed. So same way here, this is called as afferent neuron, and this is called as efferent neuron. So these two neurons will carry information in only one direction, unidirectional. It's not of bidirectional communication inside the neuron. So there will be two neurons. One is carrying information to the brain, and other one receiving instructions from brain to the peripheral organs. Similarly, we can just have a block diagram here. The central nervous system, that's what we say, the brain or maybe the spinal cord, if we put it here. Now, sensory neurons and atomic nervous system and sensory somatary nervous system. That is, if we want to have external environment interaction, so here the motor neurons will, sensory neurons will sense the external environmental signal, and they will report to the central nervous system. Central nervous system will take appropriate action and then send back appropriate action to the external environment, or maybe the motor units. Or internally, it's not that only with the external environment brain is connected. Brain is connected even to internal environment also. So from internal environment, it will get the sensory neurons will bring the information. That is, even say, if we want to speak, then it is not that, okay, our mouth can just go on producing all the voices. So it has to organize different parts of our, let us say, tongue, lip, or maybe the teeth, or in vocal cords. So a lot of muscles or tissues has to be coordinating to form a simple word. Similarly, for sitting posture, so appropriate muscles has to be positioned in whatever condition that is required. So this is the way they try to interact with central nervous system, and again give a feedback, and keep on doing in this fashion. So this way, the central nervous system will interact with external and internal environments with the help of sensory neurons, or maybe sensory neurons, both external and internal systems, and motor neurons with the systems. So this is the way that normal communication is happening. Of course, all this we know. It's not that, okay, if a very great thing is we are seeing, but all that what we are trying is, we are trying to analyze this one at say micro level, and try to see what is that we can use our engineering applications here, and maybe where actually the machine learning, or maybe whatever algorithms that we can develop can be just used here. So here what we can say is, what happens if the communication system breaks down. So when this communication between, let us say, external world to brain, or maybe internal system to brain, whenever it breaks down, what happens? Sometimes that particular path doesn't have any communication, so there may be a failure, like so many things will happen. So the life will go paralyzed. So these sort of things are the consequences of if communication system breaks. So some of the diseases, like say amyotrophic lateral sclerosis, there is a progressive degeneration of motor neurons. So or maybe cerebral palsy, which can make people to paralyze, and brain lesions leading to lock-in condition of the patients, or maybe spinal cord injury. So these are some of the conditions where the communication channels break. So these time, I mean, sometimes even whole body may collapse, or maybe some certain part, mostly for this paralytic condition patients. So brain may be functioning very normal, probably a part of external communication, and maybe motor systems might be wrong, might be not functioning. So in that condition, probably we may try to help the people with the help of our computers and maybe this machine learning process. Maybe a small introduction about, say, the brain and its functions. So in about, say, 1875, Richard Cotton observed the electrical signals from exposed brains of rabbits and monkeys. So this is the first incidence that they could able to see. There are electrical signals that we can experience from the brain tissue. And the first human EEG is recorded by Hans Berger. So this the person who could able to record the human brain signal, which we call it as electroencephalogram. So he did it in 1929, and in 1934, these two scientists verified the concept of human brain waves. So they found that the signal that is recorded is not just a random signal or noise or something, but it is having waves and oscillations around 10 to 12 hertz. So that's what they observed. So they named that band of waves as alpha rhythm. So that, I mean, it's not very known what is that, why it is happening, and what is that they could able to observe. All that what they noticed was there was certain pattern or maybe certain sinusoidal patterns, oscillations they could able to notice. So that they called as alpha rhythm. Then EEG is, if we consider EEG, is the average measurement of currents that flow during synaptic excitations of dendrites in a neural ensemble of cerebral cortex. So we can see in the coming slides, this is EEG, where actually the EEG signal is generated. I mean, whether it is one part of our forehead of our head, or maybe in the middle of the head, or where the signal is generated, we'll just see in the coming slides. So it is what they say is EEG is an average measurement of currents that are flowing inside the brain. So there are so many. If we see here, if we go into the brain, so this is the scalp, what we can see, the scalp bone, and there are dura mater, and these are the neurons. That's what we can notice. And again, as it goes like this. Now, if we try to record signals from each neuron, so this is the way what we can notice. So there will be small electrical signals that what we notice. And these signals, if we could able to directly place our recording points or recording taps from the neuron, this is the one what we can notice. But all that we could do is, or maybe whatever that has been done in 1929, so they placed an electrode at this point. Please, are you able to see my movement of my pointer?
Yes, sir. Yes, sir.
Okay. So this electrode is placed on top of the scalp. That is a bone structure, and then dura mater, and then all these things. And whatever signal is generated at this point, the inside the brain, that has been recorded from this point. So it is an averaged signal. So it is not from one neuron. It will be average signal of a set of neurons that what we are recording. So that is the one is a challenge that we can see in EEG recording and analysis. So one single neuron or one single part of the brain is not clearly identified by with the help of electrical EEG signal. And maybe whatever we record, so that recorded signal has been divided or maybe grouped as a 0 to 4 hertz frequency signal, so that they gave it as a name as a delta, and maybe 4 to 8 hertz, it is called as theta, and 8 to 13 hertz alpha, 13 to 30 hertz beta, and 30 to 50 hertz is gamma. So these are the names or labels given to the bands of frequencies or the signal that has been recorded from the brain, and there is no relation or no say derivation. That's what we can come up. All these are just like a name is given to a newborn baby. So these were just given delta, theta, alpha, beta, gamma, just names, and for these waves. But of course, it's not that very they gave very randomly, but by observing different activities, different this EEGs, and by after analysis, they came to know an understanding that and one state of mind will generate signals between 0 to 4 hertz, or maybe in another state it will be 4 to 8 hertz, or maybe other state it will be 8 to 13 hertz. So this they gave a label here, and these are the conditions when the signal will be generated. So that's what we can notice. Yeah, this is actually an electrical neuron, what we can see. So this is the one what it is called as nucleus or head of the neuron, and this is the nucleus, and these are called as dendrites. Each head will be having a lot of dendrites projected like this. This will go and get information from all sensors. So from different parts of the body, this maybe like our skin. So the touch sensors will be there. So the information will be passed to this dendrite. So this dendrite will bring the information into this cell body, and it will integrate from different parts of dendrites signal, and that information will be summed up, and then if it is going to be a useful information, or maybe it has to be recorded as an information, then a signal will be generated at this nucleus, the head, and this is called as a hillock, and from hillock it will be communicated through this path. It is called as axon, and then there are different structure of this axon, and that makes the passage of signal faster, and at the end the axon terminals will be there. These will go and connect to the following neuron dendrites. So like these dendrites, there will be another dendrites here, and that will be connected here. So this signal, whatever generated, it will be communicated to following neurons, and then that will follow to other neuron or something, or sometimes the ultimate, let us say, a muscle. Now say the signal is such that our hand has to be lifted. So now appropriate muscles has to get that information that I have to lift my hand. So that information will be given to the muscle fibers, and that is the way all that biology and biomechanics and all those things will go. So all that what we are interested is the electrical signal that will be generated in neuron, that will be conducted, and that will be delivered at appropriate place. So this is the one what is happening. Now what we are trying is whatever that signal is generated in a neuron, or especially in the brain neurons, so that we have to record. So that recording, what we call it as electroencephalogram. So of course, here what I try to see is, let me just see whether this. Is it visible, please?
Sir,
The same. No. I think there will be one more image will come on this. Is that image now visible?
no, sir.
No, only the old neuron only is there, right?
Yes, sir.
Okay, I think let us forget about that. I mean, that is only how, if it is a brain looks like, and from brain how the connections will happen, and those things are there. Sorry, I just put it I don't know if, yeah, anyway, fine. That's not a big issue for us. We are not analyzing all that. All that we have to know is there is a signal getting generated in the neuron, and that signal is transmitted to the appropriate points. So that is not an issue for us. All that issue is whatever signal is generated in the neuron, whether how we can record this is the one what our current interest. So now if we see this here, this entire region, what you can see that, I mean, there is a dotted semicircle, right? This entire area is occupied, or maybe sphere, I mean semi-sphere, what we can say. The brain is occupied inside this skull, and there are millions of neurons inside this, and those you will be generating signals, and those signals are recorded. So to record all these signals, a standard procedure has been adopted. So that is what we can say 10-20 positioning system. So electrodes are placed on the skull in such a way that, see, this is the nozzle points, and this is the inion point. So if we could able to measure the distance between the nozzle point to inion point, and this distance is being divided into 10%, 20%, 20%, again 20%, 20%, and 10%. So depending on, let us say, smaller head or bigger head, whatever head it is, so they try to put these distances, appropriate distances, and place electrodes, and they have given one name for this electrode. And similarly, there is one more line that has been drawn like this. So like this, if we can see the right side figure, so this is the center line, and this is the middle line on both right side and left side, and the side line. These are this thing. So totally, there are the yeah. If we just go to next this thing, yeah. If we go for 10-20 placements in a system, there are 21 electrodes will be there. Instead of 10% and 20%, they have, if we want to have higher resolution, they have gone for 10-10 placement. So we get about 64 electrodes, and 10-5 placement positions, about 128 electrodes. So this is the way they place electrodes all over the skull, and they record signals. So this is what gives us is whatever signal that is generated inside the brain or underneath the skull, so that is recorded from these electrodes. So now the question is, what is that? Suppose if we, because we have already seen in this, so they have given certain names for these positions, right? So now if we try to record signal between, let us say, FZ and CZ, what is the signal that we can now notice? Because for recording signal, there should be two positions. Now generally, that is the ear lobe, that is considered taken as say a reference point or ground point. So with reference to this, suppose if we record some signal, what would be the shape of the signal and how it looks like, and these are the things what is being analyzed. And if we see here, if we see where this my pointer is there, F8 and FZ. So from F8 electrode and FZ electrode, if we record, so this will be the shape of the waveform that we can notice. Similarly, for T6 and FZ, so these are the waveforms that we can notice. So here, what happens is, if we okay, here also again more these things are slides are just combined. So what happens is, suppose if we open our eyes and open and close our eyes, so there will be this sort of sinusoidal waveform rhythm in this in the signal recorded from these electrodes, whereas this signal from this one doesn't have any effect on the closing and opening of our eyes. So like that, they could able to notice some patterns. Yeah, now if we just see that brain, so if it is, this is the entire brain. So this brain is not that for every action, I mean, the entire brain will be excited, or maybe generating a signal or something like that. let us say, if we say movement, for any movement that takes place, maybe this part of the brain is active, or that will be sending signals, or sensory, this part, this region of the brain, or maybe motor sensory, and this is the one, or maybe say motivation, or maybe planning, or maybe vision. So this region of the brain. So different parts of the brain will generate signals for different activities. So this is what actually it is being observed. That's what they recorded signals and they observed, and then finally they concluded this way. It is what we can say the different lobes of brain. So they just uh, come up with the idea. So all that what we will be concentrating is on this lobe, that is vision lobe. So this is the one what we will be mostly discussing today. And other lobes are important, and that will come for different studies and all that. So this just I am giving you an overview of this. So the brain, as we say, generative and control unit. So information is gathered, so that has been sensed, and it is sent to brain. It will be processed, and the working memory will have some sort of strategy for this sort of information, how it is being what is the reaction that we have to generate, so that action will be sent out. So this is the way that what general brain will function. So if we see that a person is watching a dog and a person here, so this when it goes to brain it cannot keep as it is a memory like what our cell phone is having. So that of course our cell phone also will have its own strategy, how it stores the information. So that image is not directly stored as it is. So now this, like what we are having some compression and all these sort of things, brain will code this particular information in such a way that in this brain, so there will be some code which will be developed, and that will be representing the particular dog or man or whatever it is. So that's the way that actually it works. So this again getting back, and this is again the neurology study. I mean, a lot of the studies are coming up how the brain is coding the information, these sort of things. Yeah, see, if we see the brain, human brain, what we can do is, this is sensory system, like a vision, what we can see. This will send information to the brain, and brain will function, and it will take appropriate action, and it will be sending action control signals to appropriate neuromuscular system, so that will be communicated, and that will be executed. So this is a same thing, and what we are trying to do here is, now when it is responding to the external sensory inputs, what would be the signals that are generated, that we are trying to see. As we see that EEG, MFG, MEG, magnetic encephalogram or something. So this we will be recording. So there are maybe corticogram. I mean, directly if we record from neurons, then we call it as a corticogram. So that signal we are recording, that is the brain signal. That's what we say, EEG or MEG or corticogram, and we try to see what this signal corresponds to. This sort of, we try to analyze that. And suppose if the motor sensory interface is blocked, or maybe, as we said, due to diseases or maybe some sort of injury or some breakage happens, what we try to do is we try to use the signal and then try to interact with the external world. Now that particular aspect is called as brain-computer interface. So that's what we term, or maybe this term is coined in 2000. See, the brain-computer interface is a communication system that does not depend on the brain's normal output pathways of peripheral nerves and muscles. So brain need not have to depend on the peripheral nerves and muscles. So if it could able to communicate its signals or its ideas or its controls directly to computer, so that's what we call it as brain computer interface. This is the field that has evolved about 2-3 decades back, and it's slowly picking up interest, and then it's yielding results now. And a simple BCI system architecture uh, is, what happens is the user is here, and what we try to do is from user we try to record EEG or MRI or maybe some brain signal and whatever it is. This signal we record and pre-processing and feature will pre-process the signal and feature extraction. So we try to get the information what the brain for what reason or for what input brain has given such a signal. So that is those features are being extracted and that is classified, and the control signal is generated, and that will be given for application or as a feedback to the system, or maybe like what we can say as a speaker, or maybe as a video, or maybe any such thing it will be given. And for the system to perform well, maybe we can give a feedback so that we can try to fine tune the system. So here brain computer interface must have at least 3 components. One is goal directional intentional control, and online real-time processing, and goal-directed feedback. So these 3 blocks or units are required for brain-computer interface, or maybe the brain-computer interface is divided into 3 modules like these 3: control unit, and then feedback, and time processing. Yeah, here, what are these 3 blocks, and then how it works out is here. Criteria for brain-computer system, interface system. The system must rely on direct measurements of brain activity. That's what we say. I mean, it should get the signal, or maybe the brain activity we should be able to record, and minimum delay between the user's command and resulting feedback. So whatever that signal records, and that signal we should be able to give it to control, and maybe control should be able to give as a feedback to the BCI, whether appropriately, whether whatever the signal belong to, and the intentional what activities that has to be performed should be done at without lag, with appropriate acceptance rate. BCI system can predict only some abstract aspects of person's neurological state, cognitive state, attention, or intentions. So, of course, this is a low-pass filtering, what we can say. Say, when we are really take the efficiency of the brain, I think it is impossible to translate the complete brain's efficiency into computers. All that what we can do is we can just take a few features, whether a person is really hyper excited, or maybe he is very dull, or maybe some sedation activity. These sort of things only we could able to do. So here what it says is EEG is not completely interpreted, but what we do is we can be able to predict only a few abstract aspects of the person. So that's what we are trying here. Of course, maybe a day come when we could able to challenge the brain with our machines, but as of now, brain is the one which could able to take all control over the human body, how it has to function. But all that what we are trying is we take a few abstract features, abstract activities, then we can just try to implement. As we said earlier, so the brain segments, each segment we have already said some vision or maybe auditory or sensory decision making, these sort of things. It doesn't mean that okay, no other part can be involved in that. So far we don't know. As we know, we are trying to put it in that way. So that is the one what we understand. So now for brain computer interface, so is these are the blocks or units what we can get it, or maybe we can even put it in a block diagram form: signal acquisition, signal processing, classification, application, and stimulation. Stimulation in the sense of feedback to system. Right, this is the one. Of course, this stimulation requires, if we want to forcefully or if we want to use as a some what we can say excitation for the brain. So then this stimulation is required. Otherwise, I mean, this brain signal it doesn't generate, right? So in some cases, if we could able to get the imagination of the brain, and that imagination itself, if we take as a signal, then this stimulation is not required. But in general systems, what we are trying is we try to stimulate the brain to generate a particular signal, and that signal we just acquire, and that signal is being used. I mean, maybe we'll just see in the coming. Of course, here again the same thing, event related potential based BCI. So here signal will come, and then the event is extracted, and then that event is, maybe we try to give control. As let us say, if they here let us say the subject want to move this wheelchair forward and backward, or take a left or right turns, or these sort of things, these controls will be executed on these sort of things, or maybe opening of some window and these sort of things on the computer. I mean, appropriately we could able to do this. Major components of again here the same things, and maybe here it's for gaming or maybe some sort of activity. Say the person is playing the game by just imagining the ideas, and this signal is generated, whatever he generates, so that is being given as input to the system, because whether it has to be moved right or left or up. So based on these things, then the game will be just moved, played accordingly, and that's what it is being done. And here a robot has to pick up an object from either say from lower tray or maybe upper tray, or maybe where to keep. These sort of things are controlled by the person, not through his arms, but it should be the robot function is controlled by looking at the screen where the person is concentrating on which activity, whether the robot has to pick object from upper tray or lower tray, or these sort of things. Then we can see that what are the brain signals for BCI. So as we said earlier, I mean, the signals are generated inside the brain in the neurons. So these will be, if we directly record on the neurons, that is electrocardiography we call, and implanted electrode array is placed, and then if we could able to get the signal through let's say telemetry, we can record from cardiography in this fashion. Or it can be functional magnetic resonance imaging. So MRI signals is considered for this brain activity. So where which part of the brain is functioning and what activity is going on, this sort of thing. Or near infrared spectroscopy is being used, or maybe the signals can be electroencephalography. That's what we have discussed so far, or maybe magnetoencephalography. So a magnet is placed around the head in this fashion, and whatever small signals that are electrical signals that are generated inside the body, inside the brain. So that will be picked up by this magnetic field around, and then they try to record. So that is called as magnetoencephalography. So this is a way different ways that we can capture the signal of the brain that is generated underneath the skull. So among these things, if we just see that the greatest advantage of EEG is it is having a temporal resolution, because to get signal either in MRI or maybe magnetoencephalogram or maybe cartogram. Cartogram is also temporally high resolution, but compared to other this thing, other terms, MRI or maybe magnetoencephalogram or maybe this infrared spectroscopy, this EEG is high resolution. At the same time, this modality EEG recording system is very safe and very easy to visualize or realize in the day-to-day life compared to other things. So in that way, EEG is being used for the machine interface or maybe computer interface. So again, if we go to EEG, so there are so many ways that we can, so many type of signals that we can come across. That is slow cortical potentials, event-related potentials, or sensory motor rhythms. So the different ways that it is classified. And again, among that, event-related potentials, the exogenous and endogenous. So here, exogenous in the sense, externally we'll try to stimulate the brain and then try to get this signal generated. Whereas endogenous, just imagine a particular activity and that will be generating in the brain. So that is a little involved one. I mean, it's not so simple. So these are different ways that we can classify EEG signals. And among exogenous, the steady state visual evoked potential is one, and transient visual evoked potentials are one. So here, steady state in the sense, suppose if we take let us say our eye, suppose if a flash of light is shown to eye, and that time there will be some signal generated in the brain. So that is called as a transient visual evoked potential. Rather than that, suppose if we are giving a flicker, continuous flicker of light at a certain frequency, then we call it as steady state visual evoked potential. So that's what we call it as. If it is flicker is more than greater than 3.5 hertz or maybe 3 to 5 hertz or something, generally people will take above 4 hertz to up to 50 hertz or 60 hertz. So that time we call it as steady state visual evoked potential. So we'll just see that one, how it is, and these sort of things in coming class. Of course, coming slides. This is the one what we will be concentrating throughout our lecture. So this is a steady state visual evoked potential. Suppose our transient VEP is less than 5 hertz, whereas there is usually one visual stimulus is given to eye, and if it is a steady state, so there will be steadily with this steady interval we'll be giving stimulus. So this is the one what we call it as steady state visual evoked potential. Yeah, this is the one which is a gadget developed here. Here what we try to do is there are 4 arrows placed on a display, and these 4 arrows, though they are shown on the display, but each one is flickering at different frequency. So different frequency in the sense the upper arrow is flickering, or maybe it's going like our monitor, which will be just flickering at 60 hertz. So this upper arrow is flickering at 15 hertz, whereas right arrow is flickering at 10 hertz, and down arrow at 8.57 hertz, and left arrow is flickering at 12 hertz. And now the subject is asked to concentrate on one of these arrows, either left, right, or up or down. So when subject concentrates on one of these arrows, so then what it happens is, when it is flickering at, let us say, if suppose a subject is concentrating on 12 hertz arrow, or there is a left arrow, so arrow is flickering at 12 hertz. So when arrow is flickering at 12 hertz, in the sense, so there will be a flicker or a stimulus which will be given to eye at 12 hertz. So this is the stimulus, what we can say, 12 hertz. So this will go, the stimulus to the eye will be at 12 hertz. So whenever the stimulus is coming to 12 hertz to the eye, and if we record signal from the scalp, that too from the visual cortex, what we have seen on the back of our head. So from visual cortex, if we record signal, that is and take its Fourier transform, get only one peak. I mean, suppose these are different signals. The signal is a combination of different this thing arrows. So if we concentrate about take the signal about the when subject is concentrating on the left arrow alone, then there will be only 12 hertz peak we can notice in our FFT. And if subject is concentrating on, let us say, upper arrow, then there will be a peak we can notice 15 at 15 hertz in our spectrum of our EEG signal. So that way, what happens is, why it is 10 hertz or 12 hertz? So the stimulus is happening at every 12 hertz or 10 hertz or 15 hertz or maybe 8.75 hertz. So whenever subject is concentrating on one particular arrow, so that frequency, with that frequency only, we will be stimulating the visual cortex. So that visual cortex will be generating that EEG at that particular frequency. So when we take its frequency Fourier transform, that we can notice the peak at that particular frequency. That is the technique of all this study, what we have done and what we have discussed so far. What we are trying is, we are trying to understand the brain function, that whenever it is stimulated at regular intervals, the brain will generate EEG at regular interval. So that's what it's the principle here. And we are trying to use different distinct frequencies for different arrows. And now if we want to get let us say left movement or maybe left arrow activity, then we have to concentrate on this particular arrow, and that we can extract from the FFT of the signal, and then say, oh, now subject is concentrating on the left arrow. So now the activity related to left arrow should be performed. So that's the way what here the machine, what we try to give control and then try to move it appropriately, whatever action that has to be done. It need not have to move, or suppose if it has to be perform some activity on the computer, that activity to be done, or maybe switching off our fan, switching on of our fan, whatever it is. I mean, we can assign a particular activity to each arrow and then try to do it. So whether can it be only 4, or maybe can be more, or maybe is it what is controlling it, what is governing it? So these are the research activities that we may have to address, and then we may have to do it. I mean, that is really driving this research areas now. So we have to pay a lot of attention on this, how these frequencies can be selected, then where this say appropriate stimulus be placed on the screen, and what color we have to choose for the stimulus, that is which is best to identify by a person. These are the areas. Probably I will discuss those things also. I think we are having enough time. I think we'll go through those things. And this is the one which is developed in our lab. And in fact, he was a MS student at that time, and he could able to design this, and then along with one more PhD scholar, they could able to put it in an exhibition, and then they could able to win a first prize for that. So that's very starting point of proceeding in a big way on this BCI interface in our lab. Yeah, this is having say an Arduino board. So all of you may be practicing the same thing in your laboratories. Students are performing their lab experiments on Arduino boards. So this Arduino board interfaced with ADS1299 signal processing signal data acquisition system, and then it is interfaced to the PC, and then that will just gather the EEG required EEG, and then try to analyze EEG and try to see what best that can be done. So here the recording setup, we can just see what are the filters we use and stimulation frequencies, and software used. Of course, what we require here is only this is the occipital region what I was mentioning. So this is one signal, and maybe here is a reference, and this is the ground what we have used. So this way it has been recorded. Now, so that simple. I mean, all that we wanted or what we do is it is already known. I mean, there's nothing, no big thing and no big deal in this, right? Already this EEG is regarded and that is being translated. But the challenges are the maximizing the classification accuracy and information transfer rate of the effective online implementation. For effective online implementation is required. So all that what we discussed so far is a discretized or one event identification, one event say performance. But now if we want to do multiple actions or multiple decisions or multiple stimulus identification, then how efficiently we can do that, or what is the accuracy, and at the same time what is the information transfer rate, that is maybe based on the yes, yeah, I'm sorry, just okay. What is the amount of information, or how many bits we could able to transmit, or how many decisions we can take in 1 minute or 1 second? These sort of things are the challenging. And the dynamics of steady state visual potential. So how the SSVEP is varying over the stimulus. So here we are dealing with a biological system, that is eye, and it cannot be just like a calculated machinery that it is functioning. Sometimes it will have adaptation problem. So it may even generate much different varying over time. So as the dynamics of EEG, SSVP variation and recording procedures, all those things we have to do, and tailoring signal processing and machine learning algorithms to suit BCI applications. That's what we have to do. So for this, solution is neuroscience, instrumentation, signal processing, and machine learning, control theory. So all these things we have to combine and try to make system to function in a coordinated and well required manner. Then why non-invasive BCI is challenging. So what is the challenging? That's we notice. That's what I told earlier, but now we can see diagrammatically. So these are the, let us say, the brain neurons that are present inside the brain. So what we can say is, if we see in the magnified view of our brain, so brain will have a lot of foldings like this, and what we say cortex, and inside this there will be a neuron. It will be there. Suppose a neuron at this point is generating a signal. So now these are the electrodes that are placed on the scalp, that yellow button-like things. So when this signal is generated, so this signal is influencing this electrode and this electrode, and to some extent even this electrode or this electrode. So it will be the same signal will be, or a signal from a same neuron, one neuron will be influencing more electrodes. And at the same time, see, each electrode will be getting information from different neuron signals. So that is the challenge here. So now the conduction, the volume conduction problem. So here the signal is generated inside the volume, and it is recorded from the surface. And now to isolate the signal to the generator is a big problem. So that's what one of the challenges we have to resolve. And at the same time, as I said, the dynamics of SSVEP or nervous system is not so simple. So here what happens is, let us say if we take subjects 1, 2, 3, 4, and if we give a particular activity, that is when we say there is a 500 5 hertz stimulus, so it may generate at this point the activity of the brain, if it is mapped like this. So at this point, for S2 it may be mapped like this, for S3 it is mapped like this, for S4 it may be mapped like this. I mean, we don't know. I mean, maybe it is subject to varying signal also may be present. So similarly for different activities, 11 hertz or 16 hertz, different frequencies, in different subjects it will be differently affecting the brain, or maybe brain will be producing different signals for the same activity. So this is one of the challenges that we have to overcome. And other problems is the noise that would be, see here EEG, what we are thinking is we are recording EEG or brain signals we are recording, but it's not a brain signal alone. We are having some the muscle noise and eye movement and eye blink or cardiac signal. So all these noises also may be coming up and adding up the signal. That's what we require, and we are calling it as EEG. So there are so many noises that are present inside the signal what we recorded, and we are calling it as EEG, but it's not true EEG. So these noises we have to reduce or eliminate if possible, but elimination is not such easy thing, but at least we have to minimize these things to the best possible, depending on different criteria. If it is a hot signal, probably we have to take things that if you are familiar, so that large peak is there, no, that is a QRS complex. During that period, we should not consider the data, so that there is a lot of artifact of EEG will be there in that EEG. ECG artifact is there in the EEG. So such things, I mean, we can able to avoid. So these are some of the ways that we have to do. So these are the problems that we have to overcome. Then the usefulness of here, what we said so far was it's only the EEG signal, it is done, and there will be variation like this. So here, maybe by appropriately processing different channel EEGs, or maybe by processing different electrode signals, we can say event-related desynchronization or event-related synchronization. So these are two terms which you will come across. Of course, we cannot just make out like this. So what happens is, our brain, let us say left and right. I mean, brain is divided into left and right two parts. So left half of the brain, right half of the brain, and the peculiar the say activities, the right part of brain will be controlling the left part of our organs, whereas left part of the brain will be controlling the right part of our organs. So by placing the electrodes on the right and left scalps, then we can record if the signal that is recorded from the right half the right side of the brain will reflect the functions of the left side of the body. So like that, if we record, so one is left and one is other one is right. So here maybe I am not able to see that. Let me just see that. See, if we just go to, yeah, C3 and C4. Blue one is C3 and red one is C4. Actually, the electrodes are given a name 1, 2, 3, 4, or maybe anything F1, F2, F3, F4, or something like that. So all odd numbers are given to the left part of the brain scalp electrodes, and right side of the electrodes are given as even numbers. Now, if we say what we recorded is only two electrodes we have taken, C3 and C4. C3 is the left side brain activity, C4 is the right side brain activity. So whenever say the signal, that's what the desynchronization, what we can say here is, so C4 is going up. So C4 going up in the sense the right side brain is having a high signal energy. So when right side brain is activating, so the left side of the organ has to be functioning, like say moving of arm or moving of leg or something. So that left leg or left arm, when we move, so that will go up. As yeah, if we see here, it is opposite. Actually, the C3 has C4 has gone up and C3 has come down. This is the energy what the variations. That is the right side of movement or right side organ movement has increased the left side. Sorry, C4. Yeah, here this is C4, the right side signal because of left side organ movement. Here this is right C3, the left brain signal activity. So right side activity movement. So this is the way that what we can identify. So that's by recording EEG signal. And maybe the P300, so that is also whenever there is a stimulus or some object is being shown, so that will generate a signal that's called as P300 signal, or maybe this is what we can say SSVEP. So at equal in periodic intervals, so the stimulus will be given. So these are the some of the EEG signals that are used for the machine interface or sensory motor rhythms. So what we can just take the images of this one and then try to see which part of the brain is being stimulated. Then we can say the appropriate senses, how they are functioning and these sort of things. Or same thing whatever we explained earlier, the sensory motor rhythms, and this is what to say desynchronization, synchronization of these two left and right activities. P300, these are the signals what whenever let us say an odd ball out, so whenever there is some stimulus coming to the eye, so that the electrodes will be generating a signal. So this is what we call it as normal EEG, and whenever some oddball, inappropriate time, and something as a suppose something is like this, yes is there, but suddenly we give T, so at that time, so this is different than SS. So if it is all yes, probably the amplitude will be in this fashion, whereas something odd character has come, so there will be a peak signal that we can notice here, something like that. This is what we call the oddball paradigm, or maybe P300 type signal generation, these sort of things, or maybe steady state potentials. This will be stimulating the subject at appropriate frequency. Probably we can just see, yeah, here. See, what we try to do is, as we said earlier also, that is arrows which will be stimulating at 10, 15, 12, 8.5 hertz frequencies. Here, what we say is these are targets. Maybe these targets will flicker at different frequencies. This is one frequency, other frequency, other frequency, and subject will be concentrating on this. And then if we record the EEG and then try to find out its spectrum, we can get at what target the subject is concentrating. So that's what generally we use SSVP based BCI design. These applications of this BCI design, and if we just see the areas, see whenever there is a logged in condition, this area only, I think BCI is useful, or BCI activity is functioning, whereas in other areas where there is, let us say, detectable motor movements are there, so that BCI may not be able to function well in this, or maybe minor eye movement is there, and this is not coming for active BCI interface. These are some of the communication control for disabled. So this A, B, C, D, E, this will be characters will be there. So there some attribute we can give. As we said, each one will be flickering at one frequency, one distinct frequency, and based on that, we try to record signal and then try to identify which one is really flickering, or which one the subject want to select, and these sort of things. So these are all. Here it is P300 based signal generation, or this is SVP based signal generation. So all these things, that stimulus pattern will be appropriately designed. And here again, robotic arm control, or maybe wheelchair control. So these are some of the applications that augmented reality. So here, I mean, a person remotely controlling the activities, or maybe a surgeon microsurgery training, or maybe human automation system, or mind mirror brain activity. So by getting the how the thought process is going on in the brain, so they could able to just predict based on the signals. So here, medical diagnostics and treatment of some of the diseases, and cognitive studies, and virtual keyboard spellers, wheelchair controls, environmental controls, neuromotor processes, virtual reality, and gaming. So these are some of the areas that brain-computer interface is very actively being used. To the computer by using only either visual system. Yeah, so far we discussed only visual system, but what it happens is even hybrid BCI. So hybrid BCI in the sense, this is a multiple ways of collecting the information. So earlier we collected only SSVP, that steady state visual evoked potential. So instead of steady state visual evoked potential, it's alone. If we go for other things like say electromyography, myogram, actually electromyogram, cardiogram, electroocculogram, or motor tracking or eye tracking. So by using these activities also, rather than one, I mean, a combination of these things, then we try to do much more efficient ways. So that's also one of the areas. That's what we have to pursue, or maybe that is very active nowadays. That is hybrid BCI. So it is like this examples of hybrid BCI. So it will be, yeah, EEG signal and maybe other again EEG signal. So there is a different times that is being used. So one is motor imagery and then visual attention. So different for different conditions. So we will be trying to use different activities and then try to utilize for a particular activity. It can be either serial or maybe a parallel. So this is the way that what the hybrid BCI is coming up. Major research areas of BCI, if we can see, I mean, this is what I was mentioning. So you please try to concentrate on these sort of things and maybe try to see how best you can utilize your capabilities to come up with one of these areas. And one is the stimulus design. So the stimulus design, how we can, as I said, that frequency selection or maybe arrow selection or maybe even there are checkerboards, some sort of even color patterns. We can see different ways that we can generate the stimulus so that the attention of the eye is being kept. So that's the one challenge that is coming up. So if we can say stimulus stimulation device types, maybe sorry, earlier one is stimulus design itself, and then even device also, whether we are using CRT or LCD or LED displays, or maybe even that the frequency spectra or magnitude of fundamental frequency or number of stimuli, stimulus stability, accuracy, or flexibility of design, or maximum synchronizable frequency and user fatigue. So by taking one of these parameters and maybe the other parameters, then we try to experiment and see which is the best suited combination for us and for our application, and where we can use a particular device or particular stimulus pattern for generating BCI or stimulus parameters, whether, as I was telling, color, intensity, presence of fixation point and shape, viewing distance, dimension, or interest source distance. So there are different, the combinations will come even in this stimulus parameters also. That we have to we can concentrate. Stimulus modulation techniques, frequency modulation, multi-frequency coding, and phase coding, and hybrid coding. So different ways that I mean, you can just refer in the literature. You can find out a lot of say methods which are being already implemented, and you can add your own this thing. Okay. And signal processing, that once we do all that stimulus, whatever that we designed, and we are used appropriate device also, and ultimately we get signal, that is what we are calling in what we in this condition what we call it as EEG. So once we extract this EEG, so what is that we have to how we can maximize the information. So by eliminating noise, or as we said, a lot of artifacts will be there. So we are trying to maximize the signal. So how to do that? So for all these things, I mean, it will come up different strategies we have to use. These are some of the ones what we also practice. Yeah, signal processing. So we say whether it is a raw signal, filtered ECG, and control signal, what we can see, how it is a band pass filtering or maybe linear mapping or something. Here, spatial filters, temporal filters, and spatial spectral filters, spectrotemporal filters. So these some of the things. I mean, you have to just use. Maybe there are a lot of algorithms for signal processing. I mean, existing algorithms we try to use, or maybe we can tailor-made algorithms we can try to do. Please, if you go through literature on my publications itself, some of our students have done this, used all these sort of things, maybe the signal processing as well as the stimulus generation and stimulus coloring and stimulus frequencies and all these things. I mean, there are attempts. Please try to see that, and there is a lot of literature is there on these topics. Or spatial filtering. So as we said, no, each electrode will be getting signal from different sources. So now the segregation of this sources into space. So that's one field. I mean, we may have to just how a signal is recorded at CZ. So that signal, how much part is contributed by electrode placed at this place, neuron placed from this part of the brain, or maybe from this part of the brain. So that mapping we may have to do that. By that we may have to assume some structure and then try to map it and then try to process it, and that's again signal processing jugglery. That's what we can do. Or simple spatial filtering. That is what we try to do is, all that we understand is this is the input signal. That is, we are stimulating the signal, the brain, or maybe we are giving the stimulus, or maybe whatever we have seen shown, no, that arrow at the appropriate stimulus frequency, or maybe the red lights which will be giving at appropriate frequency, 5 hertz, 15 hertz, 12 hertz, and 10 hertz, and 8.5 hertz, 57 hertz. So that we will be giving as input, and these are the signals what we get as output. So now what we try to do is we try to compare these two things, and then based on the correlation that is having with, let us say, we are generating this subject is concentrating at let us say 10 hertz flickering. So then is the EEG, subject's EEG will be having 10 hertz. So now what we try to do, we try to correlate with all the possible filters, that possible frequencies that will be presenting to the subject. So whichever is having highest correlation coefficient, probably we can see that subject is concentrating into the particular area. So that is a simple spatial filter or something that we have to just try to implement it. I think there is no single solution which we can say, oh, this one will work well. But only thing is, we have to see the signal recording strategy, condition, and appropriately we have to design a filter and then try to implement it. And again, temporal filter, the same band pass filtering, what we can do a window and then try to see where the peaks are coming, and based on that we may have to do that different and this is the one what early, beginning slide what we have said. So maybe we have a normal programming, that is labels, or maybe what we can say decisions are there, and these are data, and then we program in such a way that the model will give appropriate decisions. So here in the let us say a training process, what we give is labels and data we can give, and the model will come. On this model, we try to give the new data and this model, then it will predict and give the labels. So actually whatever we shown as a slide 3 or 4, that same thing combined together. So first what we try to do is, in the machine we will allow it to learn the program what we there we said is a program writing. So with the help of data and labels, we are making the machine to learn the appropriate connections, and that connections we call it as model. And for this model, if we give data, new data, and it will predict which group or which decision that may come out of this data. So that's what happens. So this is a machine learning, and this is a learning process, and this is a testing process, or maybe what we can say the application process of the machine learning. And here in this model, what whatever we discussed so far, the SSVP, whatever we record, and we have already some known, sorry, yeah, as we said, known frequencies we do have. So now we try to match these things and then try to see which frequency this belongs to, or this is the way that what we try to try to implement here as this thing. And the evaluation of BCI for efficient BCI, that's what we can say. Here it is how accurately we can communicate, and at the same time what is the rate that at what rate we can communicate. These are the two important things which I already specified. So that what we call it as information transfer rate. So that has to be, I mean, this formula has been developed in the literature, and we don't have any control over it, and probably everybody is using this formula and finally coming up the ITR. So ITR means how much information that will transfer in a given time. So the maximum ITR, the better. For that, we need high accuracy and mean selection time. So the selection time should be less, and then accuracy should be high. So then we will get a good amount of information transfer rate. And the work that has been done at our lab, as I said earlier, that is Arduino board, and then AD1299 Texas Instrument data acquisition system. So this combination we are using, and then we interface to the PC, and the stimulus selection, stimulus design, and then the data recording, and then implementation. These sort of things are being done here. So this is the one actually what I said, the competition, they won the prize. So this is the unit that they designed. So basically here the stimulus design. So here there are so many stimulus. No, 1, 3, 4, 5, 6, 7, 8. Then this 3, 4, 7, 16 plus 7, 23. 23 stimulus checkerboard stimulus what we design, and try to do the transfer rate at faster transfer rate, or maybe increase this number. Once we increase, how what are the frequencies that we use for flickering of this stimulus. These sort of things we have to do, or maybe this is the other way. So there are very small number of units here, but there are for each unit again there are 8 letters. So it says there are 8 into this 5, for total 40 characters we could able to identify. But there is a different way that we have to select, we have to acquire the signal, and then appropriately we have to design. So here there is a different ways. So like this, I mean, even stimulus design, I mean, what we are designing. So this is one way that we can work on, or maybe the feature extractions. That is by using special filters and temporal filters. We are just working on this area, and now this. Thank you for the patient listening, and then we have come to a last part. Maybe I'll be happy to take some of the questions if anybody is finding it out. So it is about 11:40, and maybe we can have about 20 minutes question answer session. Sir Sridhar?
Sir, thank you very much, sir. Thank you very much, sir. Sir, thank you for valuable time and enlightening all of us. Sir, we had a hand raise from Sheikh Qasim Sahib.
Yeah, please go ahead.
Sheikh Qasim Sahib, are you available, madam? Madam, sir, Sheikh Qasim Sahib, I've seen a hand raising. Are you available? The answer is, sir, could you please check out?
Not
Sheikh,
responding, sir.
because I've seen a hand raise for around 15 to 20 minutes ago. I thought of not.
Oh, you could have, yeah, you could have just reminded me. I mean, because I could not get both the screens, so I was concentrating only on my display.
I thought I could not disturb you.
Sir,
Christian,
not responding, sir.
maybe I see that, yeah, some of them are there. I mean, the recent one, what I can notice is very useful smart online FDP. Thank you very much for organizing this. Okay, is there any brain computer simulator,
Questions?
software or hardware chip? Yeah, I think Krishnendu Mandal. Krishnendu Mandal. Yeah, there is no chip as if, I mean, we may have to just develop the system based on some, as I said, no, some computational facility and data acquisition, and no chip can be just like that it's made. But for a project, I mean, they have made some chips, and now they are incorporating inside the brain also, and trying to get the decisions. So a lot of work is going on in that way.
Sir, one other question I'm having, sir.
Yeah, please go ahead, sir.
Sir, it is like normally there are people who cannot speak and who cannot move, right, sir? Who are
Correct.
handicapped and they can sit in the chair. They cannot speak,
Okay.
they cannot move. But
Yeah.
what is the role of machine learning to implement their thoughts, sir? They want to speak.
That's what exactly that's what exactly I'm trying to see here. Suppose they could able to look at one arrow mark, right? Whether it is
Yes,
let us say right arrow mark, or maybe a block, one small block. So if they could able to concentrate, just to keep watching, glaring at that particular block, automatically their signal is converted into appropriate frequency, and that frequency will tell to the computer what activity they are supposed to do. If suppose say they want to have water, let us say if there are some 16 icons present on our screen, and each one say water, other one say coffee, other one says pencil. So if they could able to concentrate on particular icon, and then they will be that will be translated, and then they can be attended on such things.
attended by other persons.
Yeah, that's true.
Okay. So, any other questions by participants? If you have any questions, you can interact with sir. Sir, also on actually we have promised the participants
Yes,
to
sir.
maintain a repository of the all the material being shared by resource persons and any other material they provide. So if you
Yeah.
can provide this PPT or any other material, we can share the same to the participants, sir.
Yeah, you can, the same lecture you can give it, no? All, whatever I spoke, I mean, the whole lecture, you can just give it to them.
Yes, sir. Yes, sir.
Yeah,
Provided if there's no confidential information in the PPT, we can share it, sir.
yeah, please, you can share all the lecture, whole lecture. I mean, there's no problem for that.
So that the participants can go home with some knowledgeable content, sir.
Yeah. The main use of participating in this thing is I want at least a few of them. Now I can see 114 participants. At least leaving that left one, at least 14 participants will take this message and seriously, and then they implement. I'll be very happy.
Exactly, sir. Exactly.
Maybe to some extent, I mean, anybody can just mimic it at different levels. Need not have to come up with a complete system, but at least to a level, I mean, they can do that.
Yes, sir. In fact, Nachare sir and Dr. B.C. sir, you can interact with sir with your questions, sir. And meanwhile, the participants will come out. Dr. B.C. sir, are you available?
Asking to unmute, sir.
Please unmute, sir.
Sir, good afternoon, sir.
Yeah, please, sir.
Sir, blind persons is there, sir. So, if any chip is available to get a vision to the blind person, sir.
That is actually biomedical related. It won't come as say a machine learning problem or something like that. But chips are now being made. Planned. They are going by 8 by 8 or 16 by 16 matrix form, and the sensors, and they will get the scene, and let us say that 16 by 16 image, and that image is being analyzed, and that has been translated into thoughts for this blind people, sir. That is there. That project is going on across the world. Everybody is trying to their level best, what best they can do that.
Answer, sir.
Yes, sir.
Sir, that's it for now, sir. Sir, if you can kindly permit us at 12:20, we have planned for the valedictory session, sir.
Yes, sir.
So if you if you can log in by 12:10, we shall be grateful to you, sir.
Okay, I'll log out and then I'll get back around 12:10, right? What is it?
12:15, sir.
12:20. 12:15. Okay. Okay, thank you, participants and the organizers.
Thank you, sir. Thank you.
Thank you, sir.
Thank you. So I'm leaving now the session. I'll come back again at 12:15.
Yes, sir. Thank you, sir.
Okay.
Yes, sir. Thank you.
Thank you, sir.
Bye.
Thank you very much, sir. Thank you, sir.
Thank you.
Thank you, sir. Lanchare, sir.
Yes, sir.
I'll just talk about for 5 to 10 minutes. Later on, you can talk about how to give that video feedback using Flipgrid. Are you ready
Yes,
for
sir.
that?
Yes, sir. Yes, sir.
Yeah. Could you please share our proposed brochure of second phase STTP?
Yes, sir. 1 minute, sir.
So now, before proceeding, myself, Dr. Sridhar, good morning to all the revered participants from various education institutions around the country and various researchers. I'm really myself and coordinators and the team of Lindy are thankful to you because without your presence, Without your valuable participation, this program, this STTP should not have been properly materialized. So it is all, this credibility goes to all the reward participants only for taking their interest and participating in this. Now on this occasion, I just want to say a few points. Now we have in fact planned this STTP. We got funding from AICTE to conduct a series of short-term training programs on machine learning and its applications. So we have a plan to conduct this STTP in 2 phases. And in the first phase, which is going on, the one which is going on now, the first phase, this is basically being dealt with exclusively machine learning and its applications. So we have planned to cover only machine learning and its applications in this 6 days first phase program. So for which we have worked out to bring people from industry as well as people from IITs and NITs. So if you clearly observe, we have brought the resource person from various IITs and NITs, and one whole day and another half day we got resource persons from industries. So all of them have covered all the basics, fundamentals, algorithms, the machine learning concepts, and what are the basic machine learning algorithms and how they got to be applied. What are the different algorithms available in supervised learning? What are the different algorithms available in unsupervised learning? And what are the algorithms available in reinforcement learning? Not all, but at least few algorithms of each of these 3 types have been covered by different resource persons. So now at last this has come to an end. Now, as a part of conducting the second phase of this STTP, we have planned to include only deep learning, exclusively deep learning and its applications. So when it really comes to deep learning and its applications, deep learning basically deals with the usage of neural networks, the convolutional neural networks, the recurrent convolutional neural networks, FCNN, and all neural network stuff. I guess many of the people, many of the researchers, many of the participants might have heard of Alexa and Google Virtual Net. And there are many virtual assistant platforms, many chatbots from different companies around the world. To name, all of these are purely operated upon deep learning algorithms and based upon deep learning algorithms. So to address them specifically, we have divided this STTP into 2 parts, and we have divided and we have planned to conduct the machine learning concepts in the first phase and the deep learning concepts in the second phase. So the second phase, which we have planned, is going to be launched from 23rd November to 28th November. So we have actually planned to bring more number of resource persons for the second phase from industry. Because the first phase, I do agree, we have got only less number of people from industry. The idea is, in the first phase, we thought of giving the knowledge part with the resource persons from IITs and NITs. So that is the reason why we brought resource persons from IITs and NITs and less number of resource persons from industry in the first phase. The idea is to give the knowledge part from the academicians, IITs and NITs. But when it comes to the second phase, dealing with only deep learning and its applications, the second phase, the first day we have planned and we have already discussed it with Dr. Ganapati Panda sir, Emeritus Professor, IIT Bhubaneswar. I guess many of the participants are available. Sir has agreed to address all the participants on the first day.
மெசேஜ் போட்டு தொல்லை பண்ணிட்டு இருக்கு.
Hello.
Sir, go on, sir.
Am I audible to participants?
Yes, sir.
Yes, sir.
Someone accidentally unmuted it.
I thought it's a response from participant.
No, sir.
So the second phase of the program, the first day of the second phase, that is on 23rd November, we are going to have a wonderful session by Dr. Ganapati Panda sir. If many of you are aware of it, whosoever might be the resource persons coming, to address all of us. All of them are majority of them are the scholars and Sishyas of Ganapati Panda sir only. Sir is such a stalwart in the industry, known around the world. Sir agreed to address all of us on the first day. Subsequently, we have planned to have a session on exclusively on using deep learning algorithms for developing VLSA hardware architectures. This session we have planned with the industry people, and we have also planned with the sessions from NVIDIA people. I guess many of you are aware that NVIDIA people are doing extensive work on deep learning algorithms and their applications. And we are having sessions from Dr. Ashish Ghosh. Sir is head in charge of Machine Intelligence Unit, Indian Statistical Institute, Kolkata. Fortunately, sir has agreed to take 2 sessions to enlighten us, all of us. I guess many of you of the participants are aware that majority of the work on deep learning and machine learning is being happened in Indian Statistical Institute for the past many years. Luckily, the head of the Machine Intelligence Unit in ISI, Dr. Ashish Ghosh, has agreed to enlighten all of us. So, sir is going to take 2 sessions in the next deep learning STTP. So, we are also having a resource persons from Mercedes-Benz company. They are going to talk about how to use, how deep learning algorithms are being really employed in the Mercedes-Benz company with use case studies. So likewise, we are planning to have more number of resource persons so that they can really talk about how the deep learning algorithms are being currently implemented in the industry, which I guess many of us are not aware of this. So if we go through and listen their sessions, it really enlighten us. So and in addition, I'm also requesting you all the participants, if any of you are having any ideas, you can post your ideas in both the available WhatsApp groups. These 2 groups are going to be kept open till we finish the second phase, that is the deep learning applications, STTP. So in between, if you can post any of your requirements, we are going to arrange the resource persons to fulfill that requirements as well. So my sincere request to all the participants, kindly try to make the best use of the second STTP. Since morning, if you observe, I'm just trying to collect your responses, your feedbacks, your ideas only in the background, in the chat box and WhatsApp groups, because I'm trying to extract your ideas so that using which we can arrange for more number of the best resource persons in the second phase. So that is the background work I'm doing since today morning. So please, I request all of you, come out with your ideas, come out if you feel like any doubts, if you feel like any topics got to be addressed in the second phase, kindly bring them to our notice. We are going to bring the most and best resource persons from industry as well as academia. Now I leave the session open to Dr. Nanchare sir, who is the co-coordinator. In fact, at 12:20, we are going to have a valedictory session, requesting all the participants to quickly give your valuable feedbacks. I'm requesting you all, we don't require your appraisals. You can even give your suggestions, criticisms. You can talk about the positives of the STTP, which really boosts our energy as well. So please, and in the afternoon, you will be having a exam followed by, we are going to provide feedback links of the overall feedback. And also in addition, Dr. Nanchari sir is going to talk about Flipgrid website. He's going to provide a mail to all of you, a registered mail. If you can open that, you can go through the link and you can provide your video feedback as well. You can record your video feedback in a Flipgrid. The process of how to do the same, Nanchari sir is going to just talk. Nanchari sir, could you please take over?
Yes, sir. Yes, sir.
Please can you quickly provide a demo how to give feedback in the using Flipgrid.
Yes, sir. So dear participants, here is the LibGuide website. So in this we have created feedback on STTP on machine learning. So I'm going to share the link. This link will be shared with you. So when you open this link, it will ask you for the feedback. So what you need to do is you need to record a video and share your video with us so that we will receive the responses and we'll share those responses. Okay. So now I'm going to place that link in the chat box. And also it will be posted in the WhatsApp group also. So try to go to that link and record your feedback so that we'll have the feedback on overall STP. And also, whatever the feedbacks you missed till now, those feedback links also will be shared in the WhatsApp group. Don't worry about the feedback links. So all those feedbacks you can fill today. And once we fill all these feedbacks, then you will have a online quiz. So the online quiz will be link will be shared in the WhatsApp group, and you can fill that quiz. The quiz time is only for half an hour. So it consists of 20 questions. So out of this 20 questions, you need to score minimum 60% to get your certificates. And one more thing is regarding the certificates, since we have huge registrations, in order to process those registrations, and we need to get approval from AICTE, it may take more than 1 week. So once we process those certificates will be issued to your registered mail IDs. And also we'll inform about those certificates in the WhatsApp group also. Okay, no need to worry about your certificates. You will receive your certificates, if possible, within 1 week, or else it may be within next week. Okay, thank you. So please wait for the valedictory. Meanwhile, all of you please submit this overall feedback. And again, I will share you the total feedback links in the chat box and also in the WhatsApp group also. Okay, now you start filling your feedbacks.
Nansara sir, could you display that brochure once? The second
Yes, sir.
page brochure, I'll just. So, my dear revered participants, Nansara sir, could you go to the other page of the brochure?
Yes, sir.
Yeah. So, if you could please observe, kindly observe, dear participants. I'm just talking about the proposed content of the second phase STTP dealing with exclusively deep learning applications. So why I am showing these contents to all of you is, if you really feel like adding some more content, we'll just do the same and we'll try to bring out the best resource persons for the delivering lecture on them. Okay, I guess you might understand my idea, because at the end these STTPs, the outcome of these STTPs should benefit all the participants. So we want that to be achieved at any cost. So only I'm displaying this contents. So these contents read out like artificial neural network architectures and applications, different case studies, deep learning architecture and applications. We're going to have exclusive sessions on CNN, RNN, fully CNN, exclusive session on deep learning with fuzzy logic, GA and Boltzmann architecture with application. We are going to have LSTM networks, encoder and decoder. This is going to be we are having resource person from Dr. Babita Maji, Associate Professor, Central University, Bilaspur, Chhattisgarh. Madam has done extensive work on LSTM. We are also having a resource person, postdoctoral from Hong Kong University. Deep learning for signal and image processing, deep learning for NLP, the current hot topic. And one day exclusive session, we are having how to implement CNN, RCNN, FCNN using Python and TensorFlow. One full day we are going to have that. We are also going to have implementation of deep learning with a TensorFlow. One exclusive session on implementing DNN algorithms for hardware, VLS implementation, taking some Gboard and advanced boards. We are having entity recognition and POS tagging applications. So in addition to this, may I request the participants, if you really feel like adding some more contents, which really add colors to your research works, please kindly bring them to notice in the WhatsApp groups that are being kept open for the remaining 10 days, but requesting all to bring to our notice any new contents to be added before 15th of this November, so that within the available leftover 8 days gap from 15th to 23rd November, we can try to bring out the eminent resource persons for addressing your contents. So requesting all of you, you can come out with any new wonderful contents on deep learning covering any domains. Please bring that contents to our notice before 15th November, so that we are going to arrange resource persons of that topics. So try to make the best use of this. And by today evening, or we are going to even, if it is possible, by afternoon, we are going to leave open the Google Forms for registering to this second STTP. I promise you all, the participants, on behalf of the coordinating team at Lindy, we are going to provide you the more benefits and the more hands-on case studies, experiences in the forthcoming second phase of STTP, dealing exclusively on deep learning and its applications. But we need your valuable cooperation, suggestions, active participants, feedback. So at the end, we all can come out with the outcome of the STTP is being fulfilled, because the AICTE needs this outcome to be fulfilled. AICTE wants all the participants, all the faculties, all the researchers to derive the maximum benefits out of these STTPs. So you can kindly register in the links. You can provide your feedbacks. So within short span, we are going to start the valedictory. So requesting all of you to actively participate. Stay tuned for the remaining few minutes. Meanwhile, you can go through the registration links and feedback links. You can provide the same. Any queries we are going to answer at any point of time, even in the remaining days also. Please do not worry about your feedback links. Please do not worry about the materials. We are also planning to provide extra materials than what the resource persons have given to us, so that you can go home with a bunch of take home knowledge content, virtually and physically. So you can go to the links. Stay tuned for the remaining few minutes. We are going to start the valedictory session, and I promise you that's going to last within 20 to 25 minutes. We are not going to take much of your time. Thank you very much.
Sir, there is a question from Amy Joes that, sir, can you arrange sessions or applications of DL in self-driving cars using MATLAB?
Applications of deep learning on self-driving cars.
Yes, sir.
Excellent, madam. Nanchara garu, could you please note that?
Yes, sir,
Definitely we'll do,
noted,
madam.
sir.
We'll do it then, definitely. May I know who the request from the participant? Who is this, Sudhir?
Amy Joes, sir.
Thank you, madam. Amy Josh, madam. Thank you very much. It's a wonderful response. We'll try to arrange them. So likewise, I expect the participants to come out with more contents if you really feel like are going to be helpful to you. We are here to solve your requirements, address your requirements.
Yes, sir. And there is another one from Rajesh Kumar, sir, that he's saying to arrange the sessions of deep learning for medical images.
Yeah, that already we have planned, sir. Medical imaging, we have already planned. We are, in fact, we are having good number of resource persons for that. We are going to provide that, sir. Nanchara, please make a note of them so
Yes,
that
sir,
we could not
noted,
miss
sir.
all this.
That's
Yes,
it.
sir.
Any other requests, Sandy?
That's it, sir.
Yeah. So meanwhile, Nanchara, have you provided the GForm link for registering to the second phase of the program?
Sir, I will share in the registered mail and WhatsApp group, sir.
Okay, okay.
Meanwhile, I am sharing the feedback link for this session, sir.
Please do that feedback links and all, so that within 5 to 10 minutes, the participants will finish this and we can go ahead with starting the valedictory. sir. Nancharai sir. Nancharai sir. Rajan Babu sir ki Hari Babu sir ki co-host ఇవ్వండి.
Yes, sir.
ఇచ్చిన మ్యూజిక్ కొంచెం చీఫ్ గెస్ట్ సార్కి ఏదో కనెక్షన్ ఇష్యూ వచ్చిందంటే ఇప్పుడే మాట్లాడాను 1 minute లో జాయిన్ అవుతా అన్నారు రామ్ సుబ్బారెడ్డి గారు.
Okay, sir. Okay, sir.
ఒక 2 minutes సార్ జాయిన్ అవుతారు, అంతవరకు మ్యూజిక్ ప్లే చేయండి.
Okay, sir.
సార్ జాయిన్ అయినట్టున్నారు చూడండి.
Sir already joined, sir.
ఓకే అండి, ఓకే స్టార్ట్ చేద్దాం. మనం సార్ కూడా వచ్చారు కదా.
Sir, audio not connected, sir. Sir.
Source audio is not connected.
Yes, sir.
Shall I call back to sir once?
Yes, sir.
Yeah, I'll do it.
Sir, now connected, sir. Now.
Sir, good afternoon, sir. Ram Subbareddy, sir.
Good afternoon, sir. So I am audible, no? Audible and visible.
Yes, sir. Audible, sir. Audible, sir.
Okay.
Thank you, sir. Thank you for reconnecting again. So now at the outset, every great beginning must come to an end one day or the other day. So we all had a night session for the 6 days, and now that the time has come for us to end this STTP, the first phase of this STTP. So as a customary practice, before we begin our valedictory function, as a customary practice, let us have the prayer song. Nancharai sir, could you please play the prayer song?
Yes, sir. 1 second, sir.
Thank you, Nansari Garu.
Sir.
May I now request Dr. Rajan Babu Garu, Head of the Department ECE, to give his valuable message and feedback about the STTP.
Thank you, Sridhar sir. And today's chief guest, Dr. Ram Subbareddy sir. Good afternoon, sir. This is Rajan Babu, HOD of ECE department. Welcome you, sir.
Good afternoon.
It's a great privilege for us to be here, sir. And we are thankful that you are an BYS member to our department also. We are very much thankful to you, sir. And you are today's resource person. And I am appreciating Dr. Sridhar and the team who have conducted this STTP. And we are saying thanks to the AICTE for sanctioning this workshop to our department. And I'm saying thanks to all the participants on behalf of Lindy Institute of we will give our best workshop. If anybody feels that there are some flaws, please write your feedback. And the next upcoming workshop also, we will try our level best to give the best to the participants. And I hope that all the doubts, we are ready to give further information to all the participants. And team Nancharaya sir, who are behind this one to conduct this workshop in effective manner. And once again, I'm saying my sincere thanks to today's chief guest Ram Subbareddy sir. And he is a renowned person, and he is going to he is a key person in involving changing the curriculum of AICTE as well as the state government of Andhra Pradesh. Such a great personality he is, and he is also thanks to
So your voice is getting disconnected in between.
sorry here I think I used 4G network, sir. And, yeah.
Somewhere,
Somewhere some issues, technical. Okay. Good afternoon to all the participants. Am I audible, Nancharaya sir?
Yeah.
So may I now request the chief guest of today's valedictory function, Dr. Ram Subbareddy sir. Sir is none other than our honorable member of the BYS Department of ECE, Indian Institute of Engineering and Technology. Sir, I request you to give your valuable message to the revered participants and all of us. Please, sir.
Thank you, sir. Good afternoon to one and all on the net. Of course, this sort of traditional valedictory, I don't know whether how effective and this sort of thing. But anyway, this pandemic situation has given us an opportunity how we could able to exchange information and then try to interact and get ourselves enriched in this field. So, of course, the conduction of this STTPs are just to enhance our learning and maybe understanding in any particular area in a nutshell fashion, because resource persons will come from different fields and then different experiences, different backgrounds, and these sort of things, and they will be just delivering the concentrated information in that particular area. Probably the participants, either they are beginners or they are practitioners or they have a bit experience, but definitely there will be some new information that they can gather in this STTP, because it's not one person's show. It is a culmination of different minds and different practices on particular subject topic like machine learning. See, myself today I gave my view of biomedical oriented machine learning. Some other person may have some chemical industry oriented. Some person may have, say, mechanical industry oriented. How the machine learning, or maybe some people may give the computer science based how to develop a program, or maybe feature sets, or mathematical persons may look at the machine language in different machine learning in a different way, because they are the key people who, I mean, all that what we can require is we have to extract features or data patterns that what we collect, or maybe what we have experienced. So that is the key thing in this short-term programs. That's the reason why government is encouraging, and then it is very successful if we use it in a positive manner. Positive, we use it in the sense the participants, whoever either participant is like a research person is also a participant. If chance come, I mean, probably I also could have attended all these lectures and interacted with all the members. Similarly, the participants who have registered for this program, they should take this as, say, a crystal, seeding crystal, and then they should enlarge their knowledge in the area. Of course, you may not be taking the entire information that has been provided in this course, but wherever your mind sinks or maybe resonates on a point where you are interested. So then you can have interaction with that particular resource person, and then or maybe go to internet and then get some information and put in your own effort, and you can excel. If you want to attain without any guidance or without any seeding crystal, seedling point, it would become very difficult. So you might have heard in these 6 days not less than about 50 to 60 new terms in the literature. Of course, all those terms, whether they are readily available to you now or not, I mean, I doubt. But once you go through these lectures, I think definitely out of this 50, 60 new terminologies or new algorithms, new methods, and this sort of thing, at least 5 or 6 may be of more interest to you. And each one of you, please try to pursue on that and then try to excel in their career. And that is the main goal of this. And one more advantage of this pandemic situation is, see, earlier AICT used to sponsor at most 30 or 40 participants per program, because they have to be physically traveling from their places to the, let us say, the offering, the place where they are now presently the Land Engineering College. Having come here, then all the participants are to be physically accommodated in appropriate uh, way, either in a guest house or hotels or whatever it is. The burden on the organizing people used to be very high. Now this pandemic situation gave us a facility of connecting to internet from our own places and get the information. Of course, the same information we can get even in internet and all that by googling. But the way the crystallized and organized way of looking at a problem will be done by the resource people, and participants can have that advantage and then take that information and then try to excel. So that's the one positive thing we can look at it. But definitely the drawback what we are facing here is the personal one-to-one interaction or uh, physical contact is missing here. But anyway, that is has its own limitation. There is only few participants could have been presented. Now you could see 100 participants as in today. So 100 participants, I don't think any short-term program has been sanctioned by AICTE. And organizers also could have find very difficult to accommodate 100 people for one program. Unless it is a conference or something, I mean, accommodating this many people for short-term program for 6 days, it would have been very, very difficult. So that way, we have to take this advantage. Now, coming to participants' side, as already mentioned, please take these lectures or maybe, yeah, one more positive thing is here now the entire program has been recorded. That is, the entire lectures has been recorded. So you can just go through them again and again, wherever you are interested and wherever you have to reinforce a little more on that particular item. That will really help you. Like presently, of course, you also may be doing same thing, online teaching. All IIT students, they are attending online classes, and what we do is we record our lectures and then upload on the net, and the students are getting them replayed, and then they are getting correct information. If it is a class, once we speak and then we can deliver lecture. So unless student is attentive all through the class and all classes, student may not be able to get complete information. Because of this facility, regarding the lectures and posting them online, I think that advantage to students is some students, slow learning students, they are getting much convenient or much facility by this method. Same is the case in this short-term program also, because you will be getting all the notes, lectures that are being delivered in the past 6 days. So you can just go through the topics what you are interested. Please try to practice these things in your day-to-day life, or maybe in your maybe using your own resources like students or maybe libraries. Try to build and get yourself more knowledgeable in the area and try to pursue your career to further heights. And as far as I am concerned, please note down my this thing, email. You can contact me whenever you have any doubts on my lecture or maybe any area what I can able to just for some help. I'll be able to extend all possible assistance in this regard. And with that, probably I can say thanks to the organizers, especially Sridhar, who could able to constantly in touch and then say, sir, your session is coming on 7th. I mean, this is the schedule and all that. I mean, he used to contact me. And I think all of you might have got the same sort of information through Sridhar. I think he could able to uh, abide by rules, and maybe he is following timings very meticulously. And then today morning also, even yesterday evening, he called me and he said, "Sir, I will remind you morning. No need, Sridhar. I can just come by 10." But promptly he just reminded me around 9:40. Sir, this is only reminder call. Still time is there. You can just log in easily. So like that, I think he is following very meticulous timings. I hope all of us has to maintain some sort of discipline in this regard, and let us share our knowledge. Maybe if not only in this, maybe there are many more uh, occasions will come where now internet became say a medium where we can exchange and then get ourselves enriched with the knowledge and maybe facilities. I mean, exchange of facilities or networking has become much simpler now. I think this will be going to this is going to stay uh, in future. I think this cannot be removed. But whenever is possible, I think we can have even personal interactions at later stage if we feel so. I think this is really working well. Hope you also might have been familiarized with this by offering online classes. Hope the distances have come down now, and there is no physical energy spending, or maybe people traveling here and there and all these sort of things are reduced. I think, I mean, this is going to be a good workshop that you might have experienced without losing the say comforts of your own at your own zone, or maybe either college or maybe at your house. You could able to attend a conference, a short-term course, and then could get benefited by the resource lectures. Uh, I congratulate all members and the organizers for going through the 6 days on this program. Please try to make use of this opportunity to get your careers advancement. Thank you. Thank you, sir. Thank you to one and all.
Sir, thank you very much, sir.
Thank you very much, sir.
Ram Subbareddy,
Ram
sir.
Subbareddy, sir. Yeah, sir. Welcome.
In fact, we are very much fortunate enough to have you on this platform, sir. Thank you for your positive remarks and enlightening the participants. Now, before I leave the platform open for the participants to say anything, may I now invite Dr. Thamineni Haribabu, sir, Vice Principal Administration, who is representing Lendi Institute of Engineering and Technology on today. So, Haribabu, sir, could you please address the participants and all of us?
Thank you, Sridhar, sir. I think I'm audible for all of you.
Yeah, sir. Yeah, sir.
Yeah, thank you. In the beginning, it is my pleasurable wish to Ramu Sumareddy garu. And we also have Dr. Rajan Babu, head of the department EC in the fold, along with all the participants. I always feel pleasured saying Dr. Sridhar is not just one man having a lot of hands, lot of head, and then lot of energy to carry out the whole program, whatever that is left over on his shoulders. Wishing you all a very happy afternoon. We know that the world is turning topsy-turvy today. There's nothing wrong in adding any important feature in terms of anything that is coming new, as R.S. Reddy, our chief guest of the day, has already mentioned in his talk. And I also agree with him to take it forward in the name of the short-term training program, which is offered by AICTE and conducted by Lendi Institute, which also has emerged in a different line. Taking little extra advantage by being one of the speakers of this event, I would like to share an action research that I have recently undertaken. By being a teacher of English language, I understood what is this COVID-19 impact on teaching learning methodology of English. I have come up asking various teachers and then other counterparts, other stakeholders, learners also. Shockingly, I have received inputs that the teachers still wanted to equip themselves for this new normal of meeting online or conducting classes online or getting ready to take up new technologies as their major. Similarly, on the other hand, these student stakeholders too opined the same. That is a surprise for me. Even student stakeholders are expecting that there is a lot of change needed from the side of teacher stakeholder. So I am little bold, and then I also can venture into these technology teachers to understand this very important line that has been drawn by all the stakeholders who have attended an action research. So hope these kind of STTP or these kind of new number of webinars which are coming up, all might definitely help this gap to be fulfilled. Hope this STTP would have also added the similar kind of a support for all the participants. And I also tell you that Lendi is always on forefront in taking forward these kind of efforts. There are variety of initiatives that are taken up by our institution, and it is not to boldly boast it up, but it is only to put before you as a fact that this growing institution, which is working hard in bringing out these academic initiatives. To mention, AICTE has blessed this Lendi Institute by giving a lot of other activities along with this one STTP. We have had some couple of Atal FTPs. We also had Prerana with us. We have more than 6 to 7 interesting initiatives that are being supported by AICTE to carry it forward. So all this can be possible only because of people like you all who are supporting us. All the participants I've been watching, being in touch with this activity for the past 5-6 days. I've been watching the patience levels of the participants. I well remember a couple of days ago, there was a hands-on experience activity that was held where participants, even if it is online, they never have taken a step back in coming forward to experience that practical and pragmatic experience. So with this, I feel we are growing together. We are going together. Lendi is always on the forefront in taking up these challenges to carry out the best out of activities. So with this, I wish all the participants a best of luck in near future to handle that pressure of filling the gap of equipping oneself ready for the challenges in years to come or in months to come. So with this, I'll conclude by giving a congratulations note to the director of this STTP, Dr. Sridhar and his team, Mr. Nancharaya and Dr. Sridhar, all those who were instrumental in bringing out this wonderful success. With this, saying namaste, signing off, Haribab.
Thank you, Haribabu sir, for your positive, enlightening remarks. Thank you very much for sparing your valuable. Now, may I request the participants to give your oral feedback. I request the participants to raise their hands so that you will be unmuted. And before anybody raise their hands, I just want to clarify one practice which I have adopted for the past 6 days. It so happened that for the past 6 days, after the end of every session, we have provided feedback link to the participants so that they keep on giving the feedback. So the idea behind going for this mechanism is to take feedback relevant to every session. So we are doing this for the past 6 days. And in the evening also, in the afternoon, we are going to provide an overall feedback as well. So now I leave the platform open for the participants to say their feedback. Answer sir, there is a hand raised by Sivakumar Saravanan. Could you please unmute, sir?
Yes, sir, I am allowing that.
Good afternoon.
Yeah. You specify the name whom you have unmuted so that you can speak.
Yes.
Good afternoon, sir. Can you hear me?
Good afternoon, sir. You're audible, sir. Please, sir. Please go ahead. Sir. Thank you. Thank you very much for your response. Please go on, sir.
I'm Dr. Sivakumar from King's College of Engineering, Tanjavur. I am from a faculty of EEE.
Great.
For this particular STTP, though it is not a my research area, I just want to know more about machine learning and things like that, since they are the new buzzwords. But I could see that the program has been conducted with a very serious note. All the professors and experts have delivered their lectures to the core, or what I can say, to the pinnacle of that particular technology. Everybody has given the updated knowledge, updated information about that particular field. especially that one third day, I believe, one industrial person who has given us in a very packed time, he could give us plenty of inputs, which are
Yes, Dr. Pramod
for me.
Kumar.
Yeah, Dr. Pramod Kumar. It was really wonderful to say. I'm not, by saying this, I'm not degrading any other one. All the professors have done. In fact, Dr. Srinivas has dealt with the support vector machine. Right from the basics, they have started. Just like a blackboard chalk and talk method, he has used it. It was really a wonderful eye-opening session. Thank you very much. I have never experienced such a 6-day program with so much intense topics. We didn't have any break. In fact, I have carried my phone even to my restroom. That's the way I have taken up this particular STTP. I hope all the other people might have done that. It is really wonderful. It is really wonderful and informative, much informative. And the program has been conducted with much punctuality. That is to be appreciated. Special thanks to the coordinator and Sridhar sir and other members. Though we couldn't see you in person, I want to thank you. Thank you very much for the opportunity. And I have asked my colleague to attend all of the programs. The program what you have proposed to do it on November 23rd, that I have asked my colleague to attend it, and hope we will be in touch with your institution also. Thank you very much. Thank you very much for the opportunity.
That's really wonderful, sir. That's really wonderful. Thank you very much, sir. Because you told you're going to ask your colleagues also to share knowledge with us in the next session. Thank you, sir. Thank you very much
We'll
for your value.
We'll be doing it. Thank you. Thank you, sir. Thank you.
Answer, sir. Could you unmute the other person?
Good afternoon, all.
Good
I am
afternoon,
Dr.
sir.
Ravinder M., working as Assistant Professor of CSE at Indira Gandhi Delhi Technical University, Delhi. First of all, I would like to thank all the organizing committee members for conducting such a useful and informative short-term training program in online mode. I would also like to thank all the resource persons who have enlightened us by sharing their knowledge during these 6 days. I would like to say that this short-term training program has fulfilled the purpose of providing knowledge about machine learning and its applications. I came to know some useful insights about machine learning and some new research directions by attending this short-term training program. Finally, I would like to congratulate the organizing committee members for successfully conducting this short-term training program. And thank you very much for giving me an opportunity to attend this short-term training program and share my feedback. Thank you all.
Thank you, sir. Thank you very much. In fact, we are blessed to have you on this platform, all the participants. We are blessed to have you all. Answer, sir, could you unmute the other person?
Hello. Good afternoon, sir. Am I audible?
Yeah, madam. Please go ahead.
Yes, madam.
Okay, sir. I'm Saujanya, Department of Chemical Engineering, Assistant Professor from JNTU Anantapur, sir. Actually, when I have seen the registration form, machine learning and its applications, I just got an idea. We are also dealing with process dynamics and control simulation and optimization problems subjects. So I thought nowadays it is very important to attend such kind of STTPs. So I registered, and thanks for giving me the opportunity to attend this. From the bottom of my heart, I'll say thanks to the whole organizing team of the STTP, especially Sridhar sir and Nancharaya sir, for giving me this opportunity. I have learned many things: how to analyze the problem, how we can solve the problem. Especially algorithm means it's a step-by-step instructions to solve a task. So I have learned many new concepts, and also I want to thank you for the attentive poll questions, especially, sir, which made us very attentive during the sessions. And I am so, we are all very lucky to have such eminent speakers. They have given their extreme knowledge to us, and I'm very thankful. I hope, as Ram Subba Reddy sir has said, we are very lucky during this pandemic also to see in the positive mode and timely updates, prior information, and attentive responses of Sridhar sir and Acharya sir in the WhatsApp group, in the chat box. So thank you so much, sir. And I want to congratulate the whole organizing team, principal, HOD, vice principal, and management of the Lendi Institute of Engineering and Technology. And we are very eager to attend the phase 2 also, sir. I wish you all a very grand success, sir. Thank you so much for giving me this opportunity.
Thank you, madam. Thank you very much. Your positive remarks are really boosting our energy. So in the next phase, we are going to work with more vigor and valor and energy. Thank you, madam. Nancharya sir, are there any other raising hands?
Sir, but they can unmute themselves and they can talk, sir.
Requesting participants to unmute yourself and talk. I could see some hand raised. You can unmute yourselves. Right. So
new course, we need to go to new course, new course.
Hello?
No, new course, sir. I was also stuck there only. So in that, we saw that.
Nancharya sir, could you unmute all and unmute that particular person?
Yes, sir, I allowed, sir, but...
no, you mute all and allow that particular person if possible.
Yes,
Because
sir,
there's a crosstalk, I guess. There's a crosstalk.
Yes, sir. Muted him, sir. Sir, I think there are no responses, sir.
Okay. So thank you very much. I'll just take 5 minutes of the valuable time of all the chief guest of the day, head of the department, EC, vice principal, sir, and the participants. Thank you all for your patient listening because I guess your lunchtime is far approaching. Before I conclude, I just want to convey my vote of thanks. Firstly, before I say anything, I would like to say one thing. Myself and even all the participants and all of us should say thanks to the Supreme Governing Body of Technical Education, AICTE, for having provided us such a lovely environment wherein which staying at far away from each other, we could share our knowledges. Though there are physical distances, we could bridge the distances with the help of technology and supporting mechanism of AICTE. So I thank the AICTE body, the team of AICTE and the government of India for having given us this valuable opportunity to share our knowledge, to enrich ourselves with the knowledge. So followed by I convey my thanks to the management, our chairman sir, secretary sir, vice chairman sir, our principal sir, our head of the department. And at this occasion, I just want to inform all one thing. In fact, the idea of conducting this STTP, it was given to me by my one good old friend, Dr. Sudhir Reddy Garu. Is the senior consultant in Infosys. So sir has given me this idea. So only because of this idea, we have put forward the proposal to AICTE. Fortunately, AICTE sanctioned us this proposal. Thank you, sir, though you're not here at this occasion. I convey my thanks to the head of the department, Dr. Rajan Babu, sir, who is always encouraging the faculty members, the team of ECE, is always coming forward to conduct any event of this kind for the past decade number of years. And I also convey my thanks to Dr. Tamineni Haribabu, sir, Vice Principal Administration, who had been the backbone since the inception of this program, who used to continuously encourage me, give his valuable supports. Thank you, Haribabu, sir. And I convey my heartful thanks to all the resource persons, Dr. Suresh Sundaram, sir, who addressed the gathering on the first day. Followed by, we have Dr. M. Srinivas Rao, sir, Dr. B.K. Srinivas Rao, sir, Dr. Srinivas Manikandan, sir, IIT Bhubaneswar, Dr. Devi Prasad Dogra, sir, IIT Bhubaneswar, So we have Dr. Ram Subbareddy sir today, and we have Dr. Pramod Kumar from Apply World. And I convey my special thanks to the co-coordinators, Dr. B. Sridhar sir, who has always been behind me, behind the team, and V. Nanchare sir. Without the support of these two persons, I could only say one word: this STTP could not have been materialized in this way. Thank you very much, Nanchare sir and Sridhar sir. My thanks to all the faculty members of VCE, and my special thanks to not Dr. Venkatachari Garu, Assistant Professor ECE. Sir has taken a lot of pain in doing the background work. Thank you one and all for all directly involved. And my final and heartful thanks to all the participants. At the outset, I also tender my apologies to all the participants if at all any mistakes might have been committed knowingly or unknowingly. With utmost respect, you have forgiven all of us. We need your advisors. We need your kind support even in the future also. Thank you for sparing your valuable time. Thank you one and all for giving me this opportunity. Jai Hind.
Thank you, sir.
So, Rajan sir.
Sir, shall we leave the link, sir?
Yeah, sir. Yeah, sir. Sir, thank you, sir. Thank you very much, sir. Ram Subbareddy, sir.
Bye.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Thank you, sir.
Nanchare sir.
Yes, sir.
Please announce that online quiz and feedback recording.
Sir, feedback link is already shared in the chat box and also in WhatsApp group, sir. So they can fill the feedback form, and we have given overall feedback to upload the video about STTP. And at 1:30, the quiz examination will be released. So you will have only half an hour time. Within half an hour, you need to finish your examination.
And regarding that session 2 link will be putting.
Nantare sir, let us do like this, Nantare sir. I guess the time is already approaching 1 o'clock, right?
Yes, sir.
So let us keep the examination link open by 1:30 and keep it till 3 p.m. so that the participants will have some feasibility. They can finish the lunch and do it, right?
Okay, sir. Sure, sir.
So participants, please kindly make a note of this. So the examination link will be kept open by 1:30 and it will be closed by 3 p.m. Meanwhile, you can even submit your feedback responses, and also you're requested to submit your what do you call this as video recording of feedback also through Flipgrid. So that is going to be more valuable for us, all of us, because we have not seen all of you in person. So by listening to your video feedbacks, we can see you all, and hoping for the best to all of you. Let us all meet again in the forthcoming second phase of this STTP, dealing with exclusively deep learning and its applications. Meanwhile, as I've already told you all the participants today morning, so you are open with giving your suggestions and advices. Till November 15th, you can provide us the topics also, and we are going to bring out valuable resource persons to address those topics in the second phase of the STTP. I thank you all for your patient listening and cooperation. Thank you, Nancharigar.
Yes, sir. Thank you, sir. I also give special thanks to Sudhir, who is technical partner with me. And thank you, sir, for your valuable support and also your valuable thanks. Thank you, sir. I'm closing the session, sir. I will share the feed link and this examination link in the WhatsApp group, and also the second phase link will be released in the evening in the WhatsApp group, sir.
Yeah, Nancharagar, if possible, let us release that link also before 3 p.m. or so, if it is possible.
Yes, sir. Yes,
and
sir.
one final information to the participants. Whatever WhatsApp groups we people have been interacting with all till today, these two groups remain open, and daily we'll be posting you the updates. And we are also planning to post some material regularly in the groups. Please keep going through the groups and download that material. And you can even post your feedbacks, informations, your suggestions, advices for the next phase of the STTP. So collaboratively, we can conduct the second phase of the STTP as well in a beautiful way by the grace of God. Thank you, one and all. Thank you very much.
Yes, sir. I'm closing the session, sir.
Okay.